I'm recording a video for you to show how to determine the reaction order from in one of these reaction rate problems. So this is kind of a weird looking table. Maybe we can make it look a little normal. Oops, see if my pen is going to work. By dividing the columns. So this last one gives us the initial rates, and then we've got the concentrations of each one of these reactants. All right, so let's determine the reaction order of OCl minus. Let's determine the reaction order for that one first. And so the key here is when you're trying to figure out the order for one of them, you've got to make sure the other one does not change. To figure out the order for it, it has to be changing, but the other one can't because you need to only be, we're trying to figure out OCl, so we want to make sure that's the only one changing. So, and in that video I gave you, I thought it was pretty good. It explained things pretty clearly. Except for he was having you look for the ones that changed. I think it's a better idea to look for ones that don't change. So I shouldn't be changing these first two. See how it's exactly the same for I minus. So we're going to look at these two rows. Because I minus isn't changing, OCl minus is. So now let's look at the effect. We can ignore I minus, it's not changing, it's not doing anything. Let's figure out what this one's doing. I would just try to eyeball it. If it looks pretty good, then I'd just go for it. 1.7 times 10 to the minus 3, 3.4 times 10 to the minus 3. The exponents are the same, so you can just ignore that. If they're not, you can't. So check those first and decide if those are different at all. And then 3.4 is twice 1.7. 1.7 times 2 is 3.4. So, and make sure you look at the direction. I even put an arrow. So going in that direction, 1.7 multiplied by 2 is 3.4. So it's doubling. And then we're going to go figure out what effect that has on the rate. When OCl minus doubles, what happens to the rate? So, check the exponent again, 10 to the fourth, 10 to the fourth. So then we can just focus on the numbers. 1.75 and 3.5, again, that is double. You can check it in your calculator if you want to. 1.75 times 2 is 3.5. Okay, so now we figured out all we need from the table up here for OCl minus. So if something doubles, if the concentration doubles, and then that causes the rate to double, it's an order of 1. It's first order. And you can think of that as 2 from the concentration. If you have a 2 in your little concentration thing, 2 to the power of 1 is going to equal 2. So here's the thing that we're changing in our reaction rate equation, and we end up with 2. If we had put it to a power of 2, it would be squared. It would have to be 4 or something. Okay, so I don't know if that makes it more confusing trying to explain that, but that's why. So now, let me get my eraser going here. Because let's do the other one. Now we've got to figure out the order of the other reactant. You need the order of all your reactants. There could be 3. I think the next problem has 3. So we need to figure out the order of I minus, because you won't have your rate law until you have the order of all the reactants. So now we're focused on I minus, so now we need one where OCl minus is not changing. So this one's the same, and so is this. These two are identical for OCl minus. So we're looking at those two rows, and now let's check and see what's happening to I minus. Let's check the exponent, 10 to the minus 3, 10 to the minus 3. So that's the same. 1.7 to 3.4, that's doubling. It's kind of doing the same thing we saw over there. So that goes 2 times. And then what happens to the rate as really what we're saying is this is the only thing that's changing. Like when they the scientists changed the concentration in the reaction, and then they looked, here's their dependent variable, they looked to see what happened as a result of it. They saw that the result of doubling that concentration was doubling the reaction. Because here again, 1.7 times 5 times 10 to the 4 goes to 3.5 times 10 to the 4. That's doubling. So we again have like 2 to the power of what is equal to 2. So it's basically, if you find out they both stay the same, then it's going to be a power of 1. So, and let's put this in the form of the rate law. Our rate law is our equation determining the rate. Our rate law, that's supposed to be a little k. Rate is equal to our rate constant, which is k, times the concentration of our first reactant raised to the power of 1, times our concentration of our second reactant raised to the power of 1. You don't have to write these ones in. They tend to get left out. And that's our rate law. Like to do the whole process, we would actually figure out K, but let's just figure out the reaction rates. And I can show you how to figure out K in another video. So let's do another one of these. Now we've got a pretty table. So we've got a reaction, we've got all of our information about what happens when we change concentration, what happens to the reaction rate. So let's start figuring out, let's just write our little rate law. We know it's going to be rate is equal to K. It's supposed to be a little k, but I'm just going to leave it there. Times, let's do our first reaction. Reactant is I minus. And leave room for an exponent because we're going to have to put it in. S2O8, 2 minus is our other reactant. And so let's figure out the exponents that go for each one of these. So let's figure out I minus first. That one comes first. So we want to know what happens when I minus changes. What effect that has, which means that S2O8, 2 minuses should not be changing. So here's a set where S2O8, 2 minus is not changing. And look, I minus is changing. So let's use these 2 rows this time. Sometimes it's good to mark them, especially if you're skipping some, to make sure you don't skip rows, because they do tend to give you bigger tables, not small ones, like he was showing you in the video, the Edpuzzle video. Okay, so we go from 0.04 to 0.08. So going in that direction, it got multiplied by 2. It doubled. And then what happened to the initial rate as a result of that? Like, make sure you check these exponents. Sometimes they change, you don't notice. 10 to the negative 6, 10 to the negative 6. So far, they've stayed the same. So the rate went from 6.25 to 12.5. That's double. So what happens if these are the same? If this is a 2 and that's a 2, that means that this is a 1, because we're looking at the effect of changing I minus. So let's check the order of S2O8 2 minus, and then we're set. Then we have our rate law. So if we're looking at the effect of changing this one, we need to go over here and find a set over here where this is not changing. So let's see. We've got 0.8 and 0.8. That looks like about it. Oh, so let me erase this stuff. Eraser. So we can see what we're doing this time. So we said 0.8 and 0.8, those 2 are the same. See how it's easier to find ones that are the same here? If we found ones that changed over here, we might have to change our mind. So, and then let me just make sure, I like to really make sure I don't mess up and get the wrong row, because I do that, it's easy to do. So just double checking, this one's not changing, this one is. So let's see what this one's doing when it changes. Going from there to there, it's doubling, 2x. So when this doubles, what's the resultant effect on the rate? See, the exponent is the same, 10 to the minus 6. It goes from 6.25 to 12.5. That's double. And so, again, these are the same. Wow, I should have had a more exciting one where, I guess I'll have to go find a more exciting one where we get something that's actually squared, because I need to show you one of those. But for now, you have this video that shows you how to find the order of the reaction. And let's go back and figure out the overall order of these reactions. So the overall order of this reaction is what? It's 1 plus 1 is 2. And the overall order of the other one is the same. Oh, so I got 2 that worked out the same. So I'll do another video with a more complex one. So our overall order here is 1 plus 1 is 2. Okay, so you know how to do it now. I will find another one and post another one showing you one where it like doubles or triples. Okay, good luck doing these problems. You're going to do great.